Okay, here we go. Chapter 3 is linear relations and functions. This first lesson is going to cover a lot of stuff, but most of it should be review. All of this should be review. This should be review-ish. This might be new, but anyways, it's going to go quick. A relation is a connection from one set of data to another, or one set of numbers, or one set of values, or something, where to connect one set to another. It could be the number of burritos to the cost. It could be the age of a person to their height. You could relate a player to the points they scored. Independent variable to dependent variable is usually how it works with x's to y's, and that's a relation. There's a mapping to show relations. So here I've got the number 1 going to the number 12. And 2 goes to 20, negative 3 goes up here to 6. This is a mapping. A mapping takes the domain means all the inputs, or all the x values, and it maps them to the range. Range means all the outputs, or all the y values. Domain is kind of the first set, range is the second set. All the numbers in that first set are called the domain. A relation is some method of moving from the inputs to the outputs, or from the domain to the range. And these numbers right now, they don't mean anything to us, but we can find ways to make them mean things to us. There's actually a few ways to show relations. One is with a mapping, which we've talked about. One is the table. And there's a graph, and there's an equation. All 4 of those ways can show relations. So here, negative 2 goes to 6, negative 1 goes to 4, 5 goes to negative 2, 3 and 0 both go to 3. Well, same thing here. Negative 2 goes to 6, 1 goes to 4, 5 goes to 2, and 3 and 0 both go to 3. Here, negative 2 goes to 6. It's this point. 1 goes to 4, 0 goes to 3, 3 goes to 3, and 5 goes to negative 2. All 3 of these displays are showing the same relation, a way to get from the input to the output. You'll notice that this is called an ordered pair. An ordered pair is a coordinate, xy. Typically xy, but when we say an ordered pair, it means the input, the output, a single element of the domain going to a single element of the range. I hope we make that clear. Sometimes we can make an equation, and quite frankly, most of what we do in this class deals with equations, but it's not always necessary. Right now, I don't have an equation getting from here to here and here to here. It's just some relation. Like maybe we walked negative 2 miles on day 6, and we walked 1 mile on day 4, or something like that. Some relation where the output doesn't depend on the input, in which case there might not be an equation to relate them. So it's not always necessary, but it usually does happen. When every member of the domain, the inputs, each goes to only one output, which is the range, the relation is called a function. So right now, each of these inputs are all pointing to only one thing. It doesn't matter that both 5 and negative 3 are going to 21. That's not an issue. If each input goes to exactly one output, it's a function. A function is just a specific type of relation. So we call this a function because each input is going to only one output. Here, the number 16 is going to 9 and 5. That is not a function. It's a relation. You know, we've got these inputs going to these outputs. It's a relation, but it's not a function. And that's not necessarily a bad thing. It's just when we tell you something is a function, then you know each input is going to exactly one output. So here's an example of a function without any rule or equation. Let's say that a bunch of people took a test. We made a function that accepts the students as the input and gives their score as the output. So the input here, the domain, is the students, Amy, Bob, Chris, Doug, etc. The output here is their score. And let's pretend like those aren't percentages, but raw scores, like maybe 33 out of 50, as opposed to 33%, just to make them feel better. Well, sure, right now this is a function, because of course Amy can only get one score. She can't get a 33 and a 45, and Bob can only get one score. It's a function because each input goes to only one output. But say if instead of using names, we gave these students ID numbers, like Amy is student 1, and Bob is student 2, and Chris is student 3. Well, now since I have inputs and outputs that are values, that are numbers, I can make ordered pairs out of them, and I can graph them. And we can see here's student 1, here's student 2, here's student 3, 4, 5, 6, and 7. Poor little Greg didn't do so well on this one. Well, still, there's no equation here. Like, I couldn't just tell you number 3 and you could tell me their score, because the student ID number doesn't dictate how well they did on the test. So there's no equation I can make out of this, but I can still make a function where each input is going to only one output. So that's a function. Each input goes to only one output. I can't stress that enough. Each individual pairing is called an ordered pair. We've discussed that already, but this is an ordered pair sending the input to the output. The collection of all the inputs is called the domain. So right now, if I wanted to list out the domain, I would say it's 2, 3, 4, 5, 8, 12, 22. And then you put these in these set brackets. I call these wing brackets because it looks like a bird from above, like there's a cute little beak and there's two wings. But this is our domain. 2, 3, 4, 5, 8, 12, 22. I can't say 2 through 22 because there's no 6, and there's no 9, and there's no 21. So I can't say 2 through 22. I have to list out all the specific things. They're discrete numbers, not continuous, just discrete. The range, which I'll change to yellow because I wrote that in yellow. Kind of a bit of an off yellow here. I know your favorite part of these videos is watching me pick colors and pen sizes. The range is -1, 2, -6, 30, 0, 1, -2. Everything here in this column is the range. I don't want to make this clear, but this was all the domain over here. I'm going to list this in numerical order from least to greatest. So it's going to go -6, -1, 0 to 30. Now, -1 appeared twice and 2 appeared twice. I don't list it twice, just once. And it's not like these are matching up. 2 is not going to 6 and 3 is not going to -1. So I can't try to pair these up. I'm just listing out the domain and the range. Domain is the x values, range is the y values. As I said here, the word range means a few different things in math depending on what you're doing. Sorry about that, but for this class it means all the y values, all the outputs. Okay, look at these tables and determine if they are or are not functions based on what you've learned about functions. This is where you should pause and actually do that to give yourself a chance to find out. Here, on this first one, 5 goes to 2, 5 goes to 4, not a function. On this one, 5 goes to 2, 5 goes to 2, that's no problem. 5 can go to 2 twice, it's just we did 5 to 2 2 different times. Still a function because each input is going to only one output. Everything else only appears once. This is a function. Again, that's not good or bad, it's just a way to describe. 1 goes to 5, 1 goes to 5, that's not a problem. 2 goes to -10 and 2 goes to 2, uh-oh, that's a problem. This is not a function. I shouldn't use a frowny face, it's not bad, it's just not a function. Everything is going to 6. That makes it feel sketchy. But this is actually still a function because 1 is going to 6 but nothing else. And 2 is going to 6 and nothing else. And I could even write 2, 6 over and over. It wouldn't matter. This is still a function because each input is going to only one output. It doesn't matter that they're all the same output. It's just happening. The vertical line test is a way to tell graphically, by looking at a picture, if a relation is a function or not. If a graph passes the vertical line test, it's a function. Here's what that means. You draw any vertical line. And if that vertical line touches your graph at more than one point, then it's not a function. So right now, if I just put this line and kind of think of it like scanning here, that is not a function, but right here it breaks. It's touching the graph twice at this point, so it's failing the vertical line test. Because 5 is going to 2, and 5 is going to 4. 5 can't go to 2 different things and still be a function. It can be a relation, not a function. Way over here, there's no point where the vertical line hits the graph more than once. Here it looks like maybe it does, but pretend like it's just, even here it's barely going to the left, but it is. So yes, this is a function. This is passing the vertical line test. Here's our last description of a function, then I'll move on. Think of it like a menu. This is the holy grail of fast food menus. This is In-N-Out. If you go to In-N-Out and say you order a cheeseburger, it's going to cost you $2.25. So if you order one cheeseburger, it's going to cost you $2.25. And every time you order a cheeseburger, you get $2.25 for your cost. That is going to be our inputs to our outputs. And then if I get a hamburger, the hamburger is going to cost me $1.95, and why would anyone ever do that? You get a double-double animal style, everyone knows that, but maybe you're getting a hamburger because you're buying for a friend and you don't want to spend all your money, I don't know. But suppose you got a cheeseburger and it cost you $2.25, and then I got a cheeseburger and it cost me $1.50. And I didn't have any coupon, and I didn't have any special deal, I didn't know the owner or something, I just got charged less. Well then something is broken. something is not working, we would literally say this is not a functioning menu. It's not a function. It's literally not working because the same input is not going to exactly one output. It's going to different outputs, not a function, not working. Hope that makes sense. Okay, 1-to-1 is what we call a function where each input goes to exactly one output, but each output only gets pointed to once. So what I mean by this is like 5 goes to 8 and nothing else goes to 8. And 6 goes to 4 and nothing else goes to 4. If each output is only pointed to once, it's a 1-to-1 function. Onto, the term onto means everything in the range, remember the range is the y values over here, everything in the range gets pointed to, meaning there's no number that's not being pointed to. So look at these and try to determine if they're 1-to-1 and onto. Again, here is where you pause and where you look it over. It's tough for me to get all on the screen at once, so I'm going to have to do something kind of like that. Here, this got pointed to twice, so it's not 1-to-1. And this 15 wasn't used at all, so it's not onto. It is still a function because each input is only going to one output, so it is a function, but we can't say it's a 1-to-1 function or an onto function. So 1-to-1 and onto, each output is only used once. 5 is going to 2 and 5 is going to 4. That means it's not a function. Since it's not a function, it can't be 1-to-1 and it can't be onto. It can't be anything. This is just a relation. It's nothing else. If it's not a function, it can't be 1-to-1 or onto. Here, 5 goes to 2 twice. That's not a different number going to 2. It's just 5 going to 2 twice. Everything else is only used once. This is a 1-to-1 function. As far as we can tell, it's onto because every output is being used. Now, we don't know if like 6 and 3 and 5 are supposed to be in there. We just work with what we have. If onto is not making sense to you, that's kind of not a big deal. 1-to-1 and function are the important ideas here. 1 goes to 5, 1 goes to 5. 2 is going to 2 different things. This is not a function. Therefore, it can't be 1-to-1. Here, everything is again pointing to 6. This is a function. I mean, we talked about all these before. But because everything is pointing to 6, it's not a 1-to-1 function because the output 6 was used more than one time. A 1-to-1 function is where each output is only used once. An onto function is where everything that could possibly get pointed to is pointed to. The horizontal line test is what tells you if something is or is not a function. And this is where we're starting to talk about probably new stuff for a lot of you, so I should be slowing down, so I will. Remember, 1-to-1 means each output is only used once. Well, if I draw a horizontal line test, I can see that I'm crossing this here and here. I have the points -7, 2, and the point 2, 2. Well, the output 2 is used more than once. So this is a function, but it's not a 1-to-1 function. This, not a function at all. It fails the vertical line test. So it can't be 1-to-1. This is passing the horizontal line test. You can tell because the grid has a bunch of horizontal lines on it. Like, you don't have to actually draw the line, just look at the grid. It's passing the horizontal line test, and it's passing, gosh, it's being weird, oh no. And it's passing the vertical line test, so this is a 1-to-1 function. One way to think about a 1-to-1 function is it's strictly increasing or strictly decreasing, by which I mean if a graph starts going up and then at any point goes down, it can't be a 1-to-1 function because when it went back down, it crossed over some other inputs. But if it's strictly going up, or if it's strictly going down, it's a 1-to-1 function. That's the key thing to look for in a graph. Continuous and discrete is next. A relation is called continuous if there are no jumps in the graph. You can just start from one end and go to the other and keep your pencil on the paper the whole entire time. A more precise way of phrasing that is to say that the graph passes all the space between any 2 points. So this one here was continuous. This one we call not continuous because there's jumps and there's breaks. I have to pick up my pen as I'm drawing it. But the third option, there's continuous and non-continuous, but a specific type of non-continuous is called discrete. A discrete graph is a bunch of isolated points without any little segments of any sort. Like that little green thing I just drew there can't happen. Because to be discrete, you have a bunch of isolated points. So you can always be continuous or non-continuous, but if you're non-continuous, there's the potential to be discrete. Discrete means just individual points. Let's talk about that some more. Suppose I go for a walk, and think about a relation as being, well, okay, I'm sorry. A relation is continuous if I pass all the points in between. If I walk a mile, at some point, I'm guaranteed to have passed 0.522168768667866 miles. Okay? Because I'm passing all the points in between 0 feet and 5,280 feet. I'm covering a mile. I'm passing all the space in between. That is continuous. I can't go from 10 feet to 50 feet. I can't teleport. If I could, then it would no longer be continuous, but I can't. If we were to just like track my footsteps, like think about me going step, 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 step. The steps themselves could maybe be thought of as continuous because they're just hitting individual points. But like my actual body and the way that I'm moving is a continuous line. So continuous means you can't pass, or you don't have any jumps or breaks. Discrete means you just have individual points. No dragging of your feet. I don't drag my feet, then take a step, and drag my feet and take a step. That would no longer be discrete nor continuous. We just call it non-continuous. So here's a continuous line because there's no jumps in it. Here's a discrete line. It's the same function, y equals negative x plus 2, but we said x is only whole numbers. If x is only whole numbers, or I should say integers, because this could be negative apparently. But integers are positive or negative whole numbers. If x is just the integers, then all I have is these single points, and that's discrete. We see discrete things very often, actually. Think about like Dwayne Wade or Steph Curry or somebody. Can these people score 0.1 points or like 6.8 points? They can't. They can only score in 1s, 2s, and 3s. So we can connect the dots of the points they score, but that's not saying that at some point we scored all these points in between. That's just to show trends. Like we connect the dots to show trends, but that's just to give our eyes something to look at. The points they score can't pass the space in between, so they're discrete. They're not continuous. Okay, we're just about done here. Thanks for bearing with me. Linear relations, and again, a lot of this is a review. Linear relations should definitely be a review. A linear relation is a relation whose graph forms a line. All of these are linear relations. You'll note this one here is not a function. It's failing the vertical line test. This is just the line x equals negative 5.5. It's still a relation, not a function. This one here is not one-to-one. It is a function, but not one-to-one. This is line y equals negative 2.7 or something. But the key thing that's happening here that you probably discussed in geometry and you should have discussed in Algebra 1 is we're talking about, ooh, I'm missing some triangles that I want. I want this one. We're talking about proportionality. This triangle, I'm going to change its color so you can see it, but this triangle here, that's kind of a cool color, and this triangle here are proportional. They have similar features to them, same angles and proportional sides. When you have proportionality, you have a linear relation. You can draw similar triangles all throughout it. If you think about like these fractions, this is going up to, or sorry, down to, down to, down to, down to, down to. This is going up 3, up 3, up 3, up 3, up 3. You have a constant proportion in the change, and that gives you a slope. It's the idea of slope or the idea of proportion. Negative 2 over 3 is the same as negative 6 over 9 because those are the changes that you have with x and y. Change in y over change in x. So when you have a linear relation, you have a constant slope which has proportional change in y divided by change in x, which we call rise over run. That's just Algebra 1 for you. Boom, we did it. We made it. I'm going to recap very quickly, and then you can curse my name as you go home, or as you go to bed, or whatever it is you're doing. A relation is how we move from one set of data to another. They're somehow related, like people and their test scores, burritos and their costs, or distances and times. Domain is all the inputs, or the x values. Range is all the outputs, or the y values, independent, dependent. A function is a specific type of relation where each input goes to exactly one output. Do not forget that. If each output comes from only one input, it's called a one-to-one function. Vertical line test is function one-to-one, or horizontal line test is one-to-one. Continuous, discrete, linear, you got it. Thanks for watching. See you next time. Wow, you did it. You watched the whole entire math video, or you just skipped here to the end. Either way, thanks for doing it. I hope it was helpful. If you found it helpful, please share it with a friend and subscribe. And in the meantime, get mesmerized by my little sine wave I have going on here. Leave a comment below if you have any questions or comments. And I appreciate you watching. See you next time.